Hello students, welcome to Engineers Academy. Let's solve this one another problem. The problem says that determine the magnitudes of the components of force F 600 Newton acting along and perpendicular to segment DE of the pipe assembly. So we are required to find the components of this force F along this DE and perpendicular to this DE pipe, right? So we need to find the Cartesian vector representation of this force F, and so the Cartesian vector representation of force F is, we know that it will be equal to its magnitude times the unit vector from E to B, since the force is acting from E to B, and the magnitude of the force is given, which is 600. So I will write 600 multiplied by the unit vector from E to B. Then this will be equal to 600, and then we can find the unit vector from E to B by moving from E along the x, y and z axes until we reach that point B. So to reach that point B, we need to move 2 meters plus this 2 meters distance in the negative x direction, right? So I will write minus 4I. In the negative I, we need to move 2 plus 2, 4 meters distance in the negative I direction. In the negative j direction, we need to move 3 meters distance, right? So we need to move in the negative y, we need to move 3 meters distance. So I will write minus 3j. And from E to B in the z direction, we need to move 2 meter distance, and that is in the positive z direction. So this means that we need to move 2 meter distance in the positive k direction. So this is the position vector from E to B, since the unit vector from E to B is equal to the position vector from E to B divided by the magnitude of the position vector from E to B. So this, we can find the magnitude of this position vector. So I will do it directly in calculator. So this will be equal to 4 square. We will take the squares of the magnitudes of the components. So this is 4 square plus 3 square plus 2 square, and then we will take the square root. So square root 29 is the magnitude of that position vector from E to B. So this is 5.385. So 5.385. So this is the magnitude. And now if I divide this 60 by its magnitude, so 60 divided by that answer, so this is 11.14. This is not 60, this is 600. So 600 divided by square root 29. So this gives us 111.42. So 111.42. And now we will multiply this with each and every component. So we will get the Cartesian vector representation of that force F, which is acting from E to B. So 111.42 multiplied by 4. So this is 445.68 I, and plus into minus is minus, again plus into minus is minus, multiply by 3, 334.26 J, and then multiply by 2, and plus into plus is plus. So multiply by 2. This is 222.84. 222.84 in the positive k. So this is the Cartesian vector F, which is acting from E to B. Now we need to find the component of this force F along DE, which is parallel to it, right? So we can write that the component of force F along DE, and which is parallel. So we need to determine its magnitude. So then that magnitude will be equal to the force F dot the unit vector along DE, right? So we need to find the unit vector along which we want to find the component, right? So that DE, we need to write the unit vector along DE, since we are interested to find the component of this force F along the DE. So I will multiply it with the unit vector along DE. So we know that force F is minus 445.68 I minus 334.26 J plus 222.84 K dot. And as we can see that this DE portion of the pipe is parallel to the y-axis, so this means that the unit vector along DE will be equal to the unit vector along y. So the unit vector along y is j, right? So the unit vector along DE is also j. So this means that if we write complete unit vector along the j, so that will be 0i plus j plus 0k. So now if we take the dot product, so I dot I, j dot j and k dot k. So I dot I is 0, this into 0 is 0, so only the j term we will be left with the j term, right? And j dot j is 1. So we will be left with minus 334.26 into 1, or we can say multiply by 1, and j dot j. So j dot j is 1, and we will get minus 334.26 as the magnitude of the component of DE, which is parallel to that DE portion of the pipe, and this is in Newton. Now the negative sign tells us that the component of that force F along DE has an opposite sense of direction, that is to UDE, that the position vector along DE is in this direction, but the component which is parallel to the DE of that force F is acting in this direction. So the negative sign tells us the sense of the direction, right? So this is the component of DE which is parallel to that DE portion of the pipe. Now if I draw that component, so that component of the force along DE is acting like this, and then the perpendicular component of that force F, which will be perpendicular to this DE. So if I represent that, so let's say that this component is FDE perpendicular, and let's say that it is making 90 degree with the pipe. So if we consider this as a right angle triangle, right, this is FDE parallel. So by Pythagoras Theorem we can say that FDE parallel magnitude square plus FDE perpendicular square will be equal to the force magnitude square. This is by head to tail rule, right? So the addition of both of these will give us this F force, and we are interested to find that perpendicular component, so that FDE perpendicular magnitude will be equal to F square minus the magnitude of the component which is parallel to that DE square, and then we will take the square root. So then this is 600, F is 600 square minus, this is minus 334.26 square, and then we can take the square root. This is 600 square minus 334.26 square. This will give us 498.27. So we can approximately say that it is 498 Newton. So the component of that force F, which is parallel to that DE, has a magnitude of 498 newtons. So this is the solution of this particular problem. Kindly subscribe my channel and like this video for such more problem solutions.